Hello, this is Dr. Paul Cottrell, and I'm recording this on October 24th. I'd like to continue on the series on biological weapons in foreign policy. I'm doing these shorter videos to explain certain concepts. I also did a series, a three-part series that was much longer, so I'm breaking this up so individuals understand why it's so important to understand in the context of foreign policy, what is going on in bioweapon development. Now, to reiterate my previous video, it's important to understand that artificial intelligence and biological weapons are being done now. They're working together to develop new biological weapons. They're building out Stargate, which will further enhance the capability of building these biological weapons at a much faster pace. That's the key of my last video, was that the speed of computation to determine shapes of proteins and their affinity to certain receptors or certain target proteins will accelerate the development of bioweapons. But it's important to understand that there's dual purpose. There's using Stargate as weapon development for biologics to speed it up, also to create defense systems, biological defense systems, through therapeutics, vaccines, chemicals that may inhibit a certain process, so pharmaceuticals. So that would be the shield. And Stargate can help to develop the actual pathogens, modify pathogens, or create completely new pathogens. Now, there's also dual purpose, and that is that Stargate can be used to help with basic research, understanding pathologies of certain diseases, and how to mitigate some of those diseases like cancer or MS or Parkinson's. And if you understand the underlying mechanisms and pathology of that particular disease, coming up with therapies to block certain pathways or reduce the expression of a certain gene, or using gene therapy to help produce a protein that someone that is stricken by a certain disease maybe not producing naturally, to help treat patients. So it's really important to understand that Stargate's not just for bioweapon development. Stargate's for many areas of scientific endeavor, not just in biology or medicine. So just keep that in mind, is that there's a dual purpose. Now, with that said, I want to go over three systems concepts that I went over in my larger lecture series. And that is the idea of black swans, dragon kings, and gray rhinos. The reason why this is important is that as biological weapons are being developed, and the capability and the lethality can be dialed in, that and have a certain design feature, and the specificity of it is increasing, that there are feedback loops that need to be thought about. Positive feedback loops, negative feedback loops, negative externalities. Sometimes individuals will call it a boomerang. Now, keep in mind that if you release a bioweapon, that if you don't have a good shield, your population will be hit by it. Somehow, some way, by spread or by accidental exposure, a lab leak, whatever it could be, all right? But the thing is that you need to have the proper antidote. But even if you have the proper antidote, because of mutations, because of randomness, you may get something that you didn't plan. Sometimes it's positive, sometimes it's negative. In a theoretical world, you can release something that's very harmful and then find out that something actually benefits society through that lethality. Let me give you an example. You're going to have a weapon that's developed that kills off a lot of people, all right, in a short amount of time, let's say in 2 months. Biological weapon that kills in 2 months 80% of the population in a certain region. And a positive externality out of that could be that those survivors, you have now selected survivors, 20% of the population, that might have something that is a natural protective substance that they produce, or part of their genes are such that they aren't susceptible to that particular pathogen. Maybe there's a downregulation of a particular receptor. Maybe they have a certain protein that acts as an inhibitor to the pathogen, whatever it is. But let's just say that you wouldn't know that that was even the case until if something was released. So you may have a population that has a natural immunity to certain pathogens because of their genetics. All right, that's a positive externality that comes out of it. Another is that something could happen in biological weapons where there's some sort of mutation that takes place when someone's infected that leads to a small percentage of the population actually having natural immunity after being, and not adaptive immunity, but because of some sort of genomic mutation within the human body through the somatic cells. Now you go even one step further. What if there's some sort of mutation in the germline? Now the negative externality for that would be future generations would have a disrupted genome that could potentially cause disease. But you can also go down the path that a future group of people have a mutation that's affected the germline because of the bioweapon release that actually strengthens fitness within the environment. So you can do, it's not out of the realm of possibility. The point I'm making is that even if you do something very lethal and a large percentage of the people die, that you may actually have a selected group that actually is more fit permanently, not just because of adaptive immunity, but because of some sort of genomic mutation, especially in the germline. So with that, there's positive and negative externalities, and there's feedback loops. So let's look at it from a philosophical point of view. Some of these, I put them into 3 different categories. There are different categories. There are white swans and gray swans and black swans, right? But I want to just focus on the 3 big ones. And that's dragon kings, black swans, and gray rhinos. What's the difference? They're all high impact events that change a system, whatever you're looking at, a social system or some sort of complex system, biological system, whatever. So a dragon king is where there's some probability that it could happen, but when it does happen, the effects are way larger in reality compared to the prediction. So you know that it can happen. You think it's maybe a 2.5, 3 sigma event, and you think that you understand the effects if it does happen. So you know it might happen, you know the probabilities, but you don't know the full effect because of the compounding, because of the nodal effects of the system. All right. So you know the probability, but the effect is much larger. So when it does happen, it's high impact, but known probability. Now, what was not known with the Dragon King is that the full understanding of the effects. Black swans, very high impact, no probability. It's an unknown unknown. You don't know what you don't know, right? And so when it happens, you can only go post facto and look back and go, okay, these were the signs. But it's only after the fact. You don't know the probabilities because your experience is such, or the creativity is such, the imagination of whoever's doing the statistical modeling does not have the insight to realize that this event could happen and what the effects would be. And it's a very high impact event. And then gray rhinos. Gray rhinos are, you know the probabilities, but you're ignoring them. And by ignoring them, it is something that's creeping up, and eventually it happens. So gray rhinos, you know the probability, you don't pay attention. There's some sort of cognitive dissonance. Black swans, you don't know that it's coming, and you have no idea of the massive effect that it could have. A best way to describe that is an unknown unknown. And Dragon Kings, you know the probability, but you don't fully appreciate the effects, and it's a high impact event. You're aware of it, you don't have cognitive dissonance, you're trying to prevent it, but it happens and it's much larger. Something small or something benign ends up becoming very malignant. So those are the three systems to kind of get your head around in terms of biological warfare, by building biological weapons. So you got the Dragon Kings, the Black Swans, and the Gray Rhinos. So let's use it as an example for each system. Gray Rhino. All right, you know the effects of the pathogen that you're creating, and you are going to release it, right? And you also know the probability of it spilling over into other populations as collateral damage. But you're not paying it. You know this is going to happen, and you do it anyways. All right. So you have a cognitive dissonance of knowing that it can mutate once it's released. These pathogens can mutate, and that there could be collateral spillover. And you know that there's porosity within your bioshield. All right, so that's gray rhino. In terms of black swan, let's say you create a brand new pathogen from scratch through Stargate. Maybe a similar envelope that's of a respiratory virus, but you change the spike protein to attach to certain types of receptors, and you put in a hemorrhagic type virus genome. So you've merged a hemorrhagic virus genome into a respiratory virus package, right? But all brand new, all right? And you've developed this new type of virus, new type of pathogen. You have done some testing on animal models and maybe even humans in small population sizes, but you don't really know the full effects, all right, of what is going to happen. You've done some testing and you're thinking in some way, but when you release it, it does something completely different than what you expected. You thought it was going to become a respiratory infection and lead to some sort of hemorrhagic bleed out for the ones that contracted it. All right. So instead of it doing that, it ends up getting into the respiratory tract, not causing any symptoms, and ends up causing some sort of, let's say, pancreatic cancer. All right, something completely that you didn't expect, didn't test for, you didn't, but it does something in nature totally different than in the real world. That's black swan example. Now, for the Dragon King, you've created this pathogen, right? And you've done your testing, you've built up some probabilities, and you know that it's going to cause respiratory and then do hemorrhagic, and then bleed out for the patient, for the one that is contracted it. And let's say in this example where you know that the respiratory system is going to infect, right? But through your modeling, you expected that an R naught value of maybe 2, maybe 1.5, something like that. You release it into the wild, and you know that it can mutate, right? But you're not really paying attention to the mutations and the mutation rates. So when you first release it, it's working like it's supposed to. It causes an infection in the respiratory. It spreads and leads to a hemorrhagic type pathology, and the patients start to bleed out. And it's working the way it's supposed to for 3-4 months. And then there's a mutation that takes place. You knew that the mutation is going to take place, right? But you didn't fully appreciate in a larger population in the wild, in nature, what that would do. And what happens is that instead of having an R naught value of 1.5, it jumps to R naught 7. It starts to spread. And so now it's uncontrollable. That's a Dragon King. You knew probabilities of how it's going to react and the probabilities of some sort of mutation that could take place, but didn't fully appreciate that if that mutation did take place, how the R naught value may rapidly change because of some sort of conductivity within the society. Travel nodes, clusters of individuals that have certain types of genetics that could help along that mutation that leads to this explosion of the R naught value. That's Dragon King. So it's important to keep in mind that you could be developing these bioweapons and speed up the process and know much more about what could be happening at the biological level with this artificial intelligence through Stargate. But you're also bringing in these different systems of gray rhino, black swan, and Dragon King. All right. You're making something really fast. You know more about it. The specificity is larger, but you have to keep it in the context that you may know something. You may know the probabilities, and you have cognitive dissonance, gray rhino, when you're doing the development of the biological weapons. You may know the probability, but you have no idea of the high impact event when it's released in nature. You've done it in a laboratory, you think you understand it, but then all of a sudden, if it's released in nature, it goes much faster than you expected. And you're caught off guard, and your population, even with a bioshield, isn't very protective. That's a Dragon King. And a Black Swan event is that you're creating something and you release it. You think it's going to act a certain way, but it acts completely different. You let's say engineer you engineer some sort of respiratory virus, and through some sort of recombination event with maybe a different virus within a population, it ends up enhancing its feature or changing its feature in such a way where it's not acting as a respiratory virus, it's acting as some sort of, let's say, retrovirus, right? That leads to neurological dysfunction very rapidly. And that was totally unplanned. That's a Black Swan. So it's important to understand that even though you do research, even though you do probability studies, even though you do the experiments, that when it's released, things can happen in complex systems that are either underappreciated, known but underappreciated, and have super high impact. That's Dragon King. You just don't know. It's the unknown unknown, Black Swan. You know, but you have cognitive dissonance and don't care. There's apathy. So that's the gray rhino. It's very important to understand this concept of the feedback loops, complex systems, social systems, positive and negative externalities, gray rhinos, black swans, and Dragon Kings. These are all super important concepts within bioweapon development. It's super important to understand. Okay, so that's my take of this section for biological weapons and foreign policy. Now, some people may, feel that it's all doom and gloom. No, because you got to remember that there are feedback loops. As these things are developed and released, you have other people using Stargate or other systems, AI systems, to try to prevent it, creating bioshields. All right, but you have to realize that in the context of foreign policy, there's an arms race that's taking place in biological warfare. And as there's an escalation of capability of these biologics, you may end up having a Black Swan event or a Dragon King event or even a Gray Swan event. I'm sorry, a Gray Rhino event. So please pay attention. It's really important that this is discussed at a societal level, the importance of preventing further proliferation of biological weapons. Because if we don't, there's going to be an event that happens that it was either released on purpose for some sort of war or reduction of the population and or, all right? Because think about it. You have people out there. There are groups of people that want to shrink the population of the world. How are you going to do it? That is probably the most effective in a short amount of time. It's biologics. Now, but don't be fearful, all right? You have to, I don't want people to be in fear. You just have to be informed, an informed citizen to realize that artificial intelligence will speed up this process. Do you need artificial intelligence to do these things? No. You need it to speed up the process, and to increase the specificity in the dialing in of the lethality. You can design something that has low lethality. You can design something that has high lethality. You can have short-term effects and long-term effects. You can design a pathogen that actually kills a lot of people, and the ones that are still alive end up having diseases that are long lasting. You can design it where it's completely benign. It seems like something just like the common cold. But 10 or 15 years later, it's a major health issue. So please keep that in mind. Help support the work that I do by going to my website, the-studio-reykjavik.com, and donate. You can donate through Stripe, PayPal, or Buy Me a Coffee. Make sure you subscribe to all my channels. All the channels are listed in the description of this video. You can subscribe to my YouTube channels, Brighteon, Bitchute, and Rumble. You can be a paid member to my Patreon channel and my Substack channel. I do all these videos for free. If you pay attention to what I have to say, you'll have a better understanding, especially in this series, on the importance of understanding the nuances of biological weapon development and biological weapons in foreign policy. Thank you for listening, and have a nice day.